Hello everyone. Since it's office hours and no one was here, I thought I'd take the time and show you something that I think you'll find pretty cool. It's kind of in that category of bonus conversations, but it's quite relevant to the topics that in this program and in these courses. So, jumping straight in, what I want to show you today is a feature in Databricks called AutoML. And the AutoML, the ML is machine learning, so it's automatic machine learning, right? To use this particular example, what I did was uploaded our good friend, the Titanic data set, right? And so the idea here is doing some prediction of surviving, right? The experience based upon various attributes inside of the data. So the way that this works is that given that data set, you can go in and basically have this tool, and there's other tools that do this sort of thing, but what this one does is a slightly different approach. Essentially produce a series or test a series of models with parameters and essentially rank them based upon a value that you supply or select. So things like F1 or accuracy. And then at the end of the experience, you have a model that you can then deploy and use or refine depending upon on your skill. So I'll go ahead and start into it, and then I'll show you the piece that's a bit different within it. So you have the choice here of doing regression or classification. Forecasting is on its way. It's not present today. And then you have to pick your data set. And in this case, I've uploaded the data ahead of time, and fortunately I did, because there was a mistake in it. So what this does is let you see kind of the schema of the data, and then your next thing is to predict the target, as we always do when we're doing prediction. In this case, I'm going to predict survived. You give it a name. The name is really just for housekeeping purposes. Then you have some choices here of doing some additional advanced sort of configuration. The bias here is to always use F1. In this case, I'm going to go ahead and select accuracy instead, and then go ahead and kick it off. It's set here with some values of how long it'll run. That's what the timeout is. So if I leave it alone, it'll run for an hour, or it'll do 200 iterations, so whichever comes first. This is running on a cluster, and it is a Spark cluster inside of Azure, and I'm looking here at the characteristics of that environment. So basically getting a sense of how busy it is, because it's one of the things you do whenever you're dealing with things like big data analysis at scale, and using things like machine learning at scale. You want to kind of get a sense of the performance characteristics of the environment, so that you know if your loads are being distributed across the cluster, if it's all running on one of the machines in the cluster, and so on. This is a box over here. You can see that you kind of hopefully can see it. There's four squares inside of this box. One of them is the driver. That is essentially kind of the manager of the whole workload. The others are workers. You can see that none of them are terribly busy right now, because we're probably in the process of spinning up. It looks like it's 5% load on pretty much everything. So we can go back and take a look. And during that time, it's finished. It looks like 26 runs that it's completed. But it also gave us this exploration notebook, a data exploration notebook. And what this does is let us go in and do essentially our descriptive analysis of the data, and it kind of did it for us, right? So you can, you essentially, again, you attach to a cluster and you can run the code. And in this case, we're going and basically getting the data and then doing some profiling. And most of this was already done for us, so we can see what it was before, or we could run it again and see the updated results. Given the data is not likely to change, probably not a whole lot of point in doing that. So basically here we're doing calling a display HTML off of a profile which is being created for us using the pandas profiling function inside of pandas underscore profiling. And so it shows us essentially the important things that we care about of the data. For example, there's 21 warnings here of things which have high cardinality and those that have a high correlation with other fields, right? So there seems to be a high correlation between age and passenger class. There also seems to be a high correlation between sex and survived. That's kind of interesting because that's what we're trying to predict. And also the place where the various fields where they say they departed from, and so on. So there is some things, and also it identifies those items which have 0 values, right? So if there are zeros, that can be problematic. And also things that are uniform in distribution. Name and ticket seem to be uniformly distributed. So there's some pretty detailed information that gives us a sense of it. Then you can also go through and have high information about each one of the variables, and shows you basically a little histogram of the distributions. The name, probably not terribly useful because they are pretty much unique, right? So that's not going to be very predictive. Gender, 2 of them, and the various distribution, age groups, including those which are missing and have other values beyond the most commonly occurring ones, and so on. So it gives us a pretty good description of all of the data, as well as if there's any interaction between some of these things, as well as correlation, using various approaches to determine the correlation, to see if there happens to be correlation between some of these variables. And then also identification of what values are missing, and a bit of a sample of basically your head and your tail of the first and last 10 records. So while we've been going through that, it's been continuing to improve. And so the important thing here is when we go and we order it by training accuracy, and the training accuracy of 1 is quite impressive, right? Versus the various the various other values that go with that. So the worst seems to be, if we go with the other order, 60%, right? So knowing how challenging it can be to do classification on Titanic, this is actually doing really well. And in fact, probably well enough that we can go ahead and stop the experiment. So we'll go ahead and stop this and let it kind of wrap up. It knows that we did stop it. Go ahead and refresh it. And then we can basically pick one of these that is of interest. So it looks like the logistic regression is done pretty well. And basically the things that are differing here is the parameters, right? So it's tuning the parameters. So let's take a look at that notebook, because this is the part that it does that a lot of your AutoML sort of solutions don't do. It basically writes the code for you, and that's what's really kind of cool. Now granted, this is in Spark, Python, so PySpark, and you wouldn't be able to, like, turn it in a course that you're taking here, but it is pretty cool because it does, from a data scientist perspective, make your life a whole lot easier. It gives you a good foundation, even if you're going to take something like this and then refine it further. But we can go and start working through it. The first thing, this is around MLflow. MLflow is a way of keeping track of experiments in machine learning experiments in particular, and what it does is keeps track of all the runs. And in fact, when we were looking at that table, we're actually looking at all of the experiments, right, that are going on. That's what MLflow is doing for us, is it's producing this stuff. We're actually this is essentially MLflow, the output of it anyway, so a view onto it so that you can see the results over time. And what, and more in particular, and more importantly, what you get out of that is the ability to save and restore the models from that package as well. So you can actually take a model that was saved with MLflow, load it with basically 1 or 2 lines of code, and then expose it through a service endpoint as like a web browser or a web available REST API. So going through the data, we start off, and they actually, if you'll notice, included nice little documentation based with hierarchical levels and so on. So you've got load data telling you what they're doing, and as the name implies, it's loading the data from essentially in a Parquet format from the training data set. So it's reading it in, loading it, and then it sets up a series of preprocessors. So there's a list of preprocessors that will be done. and in particular, we're really only doing one here, which is a simple imputer, which essentially is going to replace any missing values, and it's going to do that with most likely it's the average value for the other ones that are present. So p-class, p-arc, and our sibling count. So go ahead and run that, and it's basically just filling in the values, assuming you actually run the commands in the right order. Then it uses it handles the categorical columns because it detected that they existed, and it uses something called a one-hot encoder, which is something you learn about whenever you're taking classifications. It's a way of essentially turning things like strings or even various values into something where it's a lot easier to handle. It's essentially a bit of things that are turned on. And it's also including a simple imputer here with the one-hot encoder, and it's doing this inside of this ML the sklearn pipeline. So it's doing a pipelined architecture, which is the right way to be doing this. So the code that they're writing is actually very well written, as well as being quite useful. Then we go through and do some column, we set up what column transformations we want to do, and then we do some standardization, which is always a pretty good idea. So a standard scaler, bringing things into something centered around 0 with unit variance. And so the next step is accidentally turned on. Turn that off, an accessibility thing. Sorry about that. Found a Windows feature that I didn't know existed, so don't hold down the right shift key too long. So moving on, we did the standard scalar, so we're basically making sure things are of a uniform variance. So that we don't have one thing overpowering the others. And then the next step is to do our typical split, train test split. You'll notice this is code very similar to what you've done or probably will see in future courses. And then we define our model. In this case, we're going to use logistic regression. So we start by importing it, and then we go through the process of actually creating an instance of it. And again, using a pipelined approach with a preprocessor, a standardizer, and sklearn classifier. Once it's created, again, this is where you see that we're sending a call into ML or auto ML flow. So we're doing some auto logging, and that's what's making this whole thing easier to reproduce and so on. And it's giving us back a slightly different number than we saw on the test set, but still a respectable precision score of around 90. So 90% is nothing to sneeze at. And then we go through and we can do some analysis of feature importance. So what features seem to be the most important whenever we're doing our prediction, something that is also fairly common that you'll find yourself doing later on if you haven't done so already. So this is a way of figuring out of a given data set, whenever you're trying to use it for something like prediction, what values are actually really being effective and what ones are not so effective. So the part of the reason you do that is oftentimes you'll prune those that are not so important, so you'll focus in on the ones that are. So it's going through running that calculation and then showing us the ones that do seem to be the most important, which is a little different because boat and home destination seem to be pretty significant. So things to consider. Sometimes you learn things, and then this is the part where you can actually start using it. So you can use the model registry to essentially register this model and start serving it out there. So in this case, you can actually go and load the model up and start showing it as something that could be consumed. So again, this was just something that I thought you might want to see as a kind of a filler while I wait around to see if anyone has any questions. So again, the focus of these times is to be available to answer questions. If you have some ahead of time, feel free to let me know. Also, I'll be around until roughly the top of the hour. So let me know if there's any questions you have along the way.